Right, the first one. All right, so today will be a lot of me explaining, and you guys just try to understand and follow. All right, I'll check in on you guys once in a while, but we only have like 2 lessons left. So the only thing I can do is to give you guys as much knowledge as possible. Okay, so try to absorb. So how make sure you don't stare at my face and not listening at all.
Yeah.
Okay, that's a mistake that you tend to do a lot. All right, so you actually have to think about the question. All right, so we have limited time, but of course I will record this. So if you guys want to go home and then watch over the recording again, it will be available here. Okay, whatever questions I'm going through today, since you guys won't have time to actually go through it, it's all in that sheet there. So you guys will have to go back, and if you guys want to practice, then you have to redo the question at home yourself. Remember, recognition and recall. Right, you guys recognizing my answer is only the first step. The ultimate step is for you to do the whole question by yourself without any help, without watching anything or reading anything from start to end. Get to the right final answer, flip over, check your answer, correct, then you're done. Okay, so once you've got to that point, you can cross the question off from that sheet there. That sheet has a lot of questions. Okay, ideally, if we got to the point where I give you guys this sheet, say a month before the exam, then maybe you can finish all of it. But now it's very difficult to finish all of it, considering you also have revision from school and stuff like that. All right, so at least do the questions that I go through in class today, because if I go through them in 2.5 hours, you only take about roughly the same amount maybe to go through them at home. Okay, all right, so the first question I will go through will be something from question 1 here. Okay, most of the time you guys should be able to do most of these questions. However, there are 2 questions in here that I think you guys might have some struggle with. The first one is C. All right, can someone tell me what is the rule to derive C?
Derive the power and then bring it to the front.
Derive power brings it to the front. Okay, so you're saying F dash is derive the power, so -5 xe power -5x. Sorry?
Is it a quotient rule?
Not quotient rule. Product rule, yes. It is a product rule because this is a function of x times by another function. Very basic mistakes, okay? I've seen students make so many of these mistakes before. It's actually a function times into a function. So you need to use the product rule where this is u, this is u and this is v, u times v. Which means that this will be u dash v plus u v dash. Remember, you always derive which one first, u or v? You always derive u first for both quotient and product rule. So you derive that first, that will be 1. V would be e to the power -5x plus u is x, and then when you derive e to the power -5x, then you derive the power, which is -5, and then you get e to the power -5x. Okay, so rearranging that, you got the first derivative is e power -5x, and then if you want, you can take it out as a common factor, then you get 1 minus 5x. Okay, does it make sense? Yeah. The reason why I do that is because you will have to do another product rule anyway, and might as well take it out, and then when I do the second derivative, I will need to do the product rule again. So f double dash x would be you derive u, right? This is u and this is going to be v. So u dash v plus uv dash is always good to write down the rule first. Okay, so -5 e power -5x, and then times by v, which is 1 minus 5x here, plus u, so you keep this thing, and then you derive v, which is, what's the answer? What's v dash?
Wait, which one is it? Oh, that.
-5 e to the power of -5x.
Yes, that's right. So I already wrote the e to the power thingy here. So yes, the only thing remaining is -5, which means that these two, so that one, right, these two and these two are common factors. So once again, we take out the common factors, -5 e power -5x. Then in the brackets, I will have 1 minus 5x and then plus 1. Okay, so then the factorized version, the final answer for the second derivative, will be something that looks like this for the factorized version, 2 minus 5x. Okay, so that should be the answer for the second derivative. Any question? Any question? All good?
What would it?
Yeah. Okay. Right. So that's the first one, and then what's the derivative for e? Well, this is not too hard, but it could just be a little bit tricky. So let fx equals to cos of pi x on 2. What is the first derivative?
Negative 1 over 2 sine pi x over 2.
Negative 1 over 2 sine
Yeah.
pi over 2?
Pi x over.
Pi x over 2?
Yeah.
Almost correct.
You're using a pi in the top.
Where? Yes, it is negative pi over 2. The coefficient is pi over 2.
Yeah. Not 1 over 2. Yeah.
Okay, you see the common mistakes now? Literally just made right here.
Yeah.
So be very careful. Alright, so then the second derivative is sine would be cos. Then what's the second derivative? Can you do that in your head?
Doesn't that just become still negative
Negative?
pi over 2 cos pi over 2x?
Yep. Or pi x over 2.
Pi x over 2.
That's it?
Is that it?
That's not it.
Pi squared over 4.
It is pi squared over 4. Do you see why it's how? You should be able to see why. If you don't see it,
Pi times pi.
sorry? It is this number, and then when you derive it, you need to chain rule it again, and you times it by the derivative of the inside, which is the coefficient of x.
Wouldn't that be 2 pi over 4?
No? Pi times pi is pi squared.
Oh yeah.
Okay? Alright, so how... Just for you, I expected you to do this question perfectly by now. If not doing enough homework. Not doing enough work to revise this. This is easy. Alright, now we'll touch on something that's a little bit harder. So tech 3 again. I think the second half I'll do some tech active questions, maybe complex unfamiliar or something. Alright, but there are many questions. I'll tell you guys what to do with the multiple choice questions. Alright, this one here. Find the first derivative so that it is more than or equals to 0 for all x, and then show that the only stationary point is the stationary point of inflection. Okay, alright. So for question A, first derivative. Now we've got the main equation here. If you want, you can actually write out the expressions u and v so that it's a bit easier to manage. Okay, so then u dash equals to 1, and then v dash equals to, now you got a e to the power of the same thing, and then you derive the power, which is 4x minus 4 times e to the power this thing. Okay, alright. Then the first derivative would be equals to u dash v plus uv dash. Hey Suleiman, how are you?
Thanks. Sorry, I'm a bit quick.
Yeah, that's alright. Let's get, we're getting started into the harder questions. Alright, so I was telling the other two, today I will be going through a lot of questions. You guys won't have time to do any of these, so just try to follow along with my working. Okay, and you guys need to go back and redo these questions later. Yeah, try to see if you can do it before I say it. If you're confident, you gotta do it before I say it. Okay, so again, focus on my working here. So that's f dash, and which means when I'm trying to derive it, I'll times u dash with v, which is e to the power 2x squared minus 4x. So that times that, and then this times this. So that will be plus, I can quickly combine them. So it'll be 4x squared, or I can write it as x times 4, actually no, I'll write it as 4x squared minus 4x, right? Everything in brackets times by e to the power 2x squared minus 4x. Okay, next step is, what's the next step?
Expand.
Not quite.
I'll take a common factor.
Sorry?
Take a common factor.
Yes, you take out a common factor. Okay, then what's in the brackets, Emily?
1 plus bracket 4x squared minus 4x.
Yep, okay. But you see, if it's plus and then just two terms, you don't need the other brackets. Okay? Now, question B. Show that this is more than or equals to 0 for O of x. Okay, how do we show this? Well, the first thing you can do is see what kind of equation this is. Quadratics. Can we factorize this?
If you rearrange it, can you?
Yep, you should rearrange it. Yes, that's right. 2x squared minus 4x, and then this one would be 4x squared minus 4x plus 1. Okay, so what's the ACB table look like?
Yeah. 4x squared.
Minus 2, minus 2.
Yes, what you're saying is the answer, but I'm looking at the AC, so the A times C value, which is 4 times 1, that's 4, and B is negative 4. So you want factors of 4 add to negative 4, which is what you said, that's negative 2 and negative 2. Remember this, factorizing quadratics? Okay, many questions, it's just made it harder because of quadratics. Now, why am I trying to factorize this? Now, remember, when you're trying to show something more than or equals to 0, right? That means that you need to show, if you have like something like A times B, 2 factors, okay? Because this one, E some power something is a factor, and then the bracket is another factor. If you have 2 factors multiplied together, like A times B, you try to show this is more than or equals to 0. If you can show that this is always more than or equals to 0, and this is also always more than or equals to 0, then the product must be more than or equals to 0 as well. Does it make sense? Yeah, because if one of them can be negative, like if B can be less than 0, then the product will not be more than or equals to 0. Right, so that's the general idea. Any question? No?
You said it has to be more than or equal to 0.
Or more than 0. Either way.
Are they both negative? So like
so each of the factors has to be more than 0. Right? Because you want the product, you want to show that the first derivative is more than or equals to 0. Right? Which means whatever the function for the first derivative is, it has to be over the x-axis. Right? It can touch the x-axis because of the equal, but otherwise it has to be over the x-axis. Does it make sense? Yeah? And in order for the whole function to be over, if there are 2 factors in there, each of them must be at least equals to 0 or more than 0. Right? So when you look at this one here, you can, so that's why I'm trying to factorize this. And I'm trying to see what kind of equation this one is. Is it going to be something that's strictly more than or equals to 0, or can it, because remember, quadratics, right? You can either have like that, so strictly more than 0, or you have touching the line, which is more than or equals to 0, or you could have something that looks like that, right? Which is like, it can be positive or negative. Okay, does it make sense? This is a normal parabola. Right? How do I know this is a normal parabola? How do I know this one is a normal parabola, not an upside down one?
Because the starts with negative, so the x squared is not negative.
Yes, because the x squared term is not negative. Okay, and that's how I know that it's going to be positive. So it's either one of these 3 forms, right? And we want to prove that it must be these 2 and not the last one. Okay, so let's see what we can do. So once you've got ACB table, at this point you can say that, okay, actually, I'll draw it here. Okay, so rewrite the first part. Oh, okay. If you want to break it up into 2 parts, so you can go consider e to the power 2x squared minus 4x. Okay, this is or you can write like since this one is always, so e to the power x squared minus 4x, since this is always more than 0. Okay, no, actually, okay, maybe I'll rewrite this a little bit. So note that this one is always more than 0. Right, just put a note here, and then you can say, okay, this is argument number 1. Okay, do you guys know why it's always more than 0? Yeah, Suleiman, why?
Because it's a log function, e exponential.
Yes, because it's an exponential function. E to the power x, right? The main equation will look something like that. Doesn't matter what x is. Okay, e to the power of anything, because the base is positive, it can never cut through the x-axis. Right, that's why it's strictly positive. Now, and then now we consider Now we need to consider the other one. So 4x squared minus 4x plus 1. Okay, so I'm breaking that up so that the writing is a little bit shorter. I don't need to keep on rewriting the e to the power 2x squared minus 4x all the time. So I consider this one. This is equals to, we've got the ACB table, so we will split middle term up. So that'll be minus 2x minus another 2x plus 1. All right, take 2x out. That will be 2x minus 1. And then take out minus 1, then you'd get 2x minus 1 as well. And then take out the common factors, you would be 2x minus 1 times 2x minus 1, which is 2x minus 1, everything squared. What does that tell us?
This is one solution for x.
Sorry?
One solution for x.
Yes, there will be one solution. What else? Remember, what are we trying to prove? Question B is, show that the first derivative is more than or equals to 0 for all x. Right, and remember I was saying earlier, if there are two factors, each of them must be more than 0 or equals to 0. It can't be less than 0.
Wait, you say like since it's squared, then even if it's a negative, it will also be positive?
Yep. So you can say, you can simply make the conclusion that this is more than or equals to 0 right here. Does that make sense? Yeah. And so you can say this is argument number 2. So from argument number 1 and argument number 2, from these 2 points, f dash of x must be more than or equals to 0. So this is the final answer for question B. Does that make sense? So this question B is a little bit different. When they ask you to show that, you need to show it using some mathematical forms. Okay, and in this case, it's using the fact that the product of two factors. You use that. Okay, so question B technically starts from here. All right. Hence, show that the only stationary point is a stationary point of inflection. So how do we show this? Well, note that we already factorized, right? We factorized the first derivative instead of this form into this one, right? The second part will turn into this one here. So C from part B, we have the first derivative is equals to the E part minus 4x and then times by 2x minus 1 everything squared. All right, make sense so far? Okay, so to find stationary points, you set that equals to 0. Okay, find stationary point, which is f dash is equals to 0. So you get 0 equals to e to the power 2x squared minus 4x times by this thing. Okay? Right? Make sense? Yeah? And then because the e power something can't be 0, which means this one must be equals to 0. And to find the stationary points, bring the 1 over, divide by 2, 1/2 equals to x. Okay, this is the x at the stationary points. Now, look at the question again. Show that the only stationary point, so we know that there's only one stationary point, is a stationary point of inflection. How do we do this?
Test the nature.
Good, test the nature. How?
With the table, or can use the second derivative.
Yes, that's right. Test nature with second derivative. Okay, so once again, this is the first derivative. All right, now that you can do the second derivative, but when you put 1/2 into calculate, it will be a little bit tricky. All right, because when you derive this, it is a really long thing to derive, right? It's a product rule. So you can, in this case, you can use the table, right? I'll show you how to use the table with gradient table. So if it's too hard to derive it twice, you can use the gradient table. So x here and then f dash. There's only one point anyway, right? And then the shape. Okay. So if you at this point, there is something that you can do in the exam to cheat a little bit. Okay? If you are in a hurry, so I'll show you. So we know that at 1/2 it's 0 and the gradient is horizontal, right? And we just need to find the point before and after. What did they ask us? Show that the only stationary point is the stationary point of inflection, which means we know that the shape is either like this, or down, and down. Does it make sense? Yeah? Oh, sorry, not f dash. It should be the shape like that, right? Either one of those two. Does it make sense, Al? Yeah? Make sure you follow. So it's either up and then horizontal and then up, or down, horizontal and then down, right? Which means that if you want, you can just calculate one value. So for example, I'll calculate when x equals to 0. Because when you put that into the derivative, this one here, it's pretty easy, right? So at f dash of 0 would be, you have to calculate that would be e to the power 0, because 0 minus 0 is 0. So e to the power 0, and then 2 times 0, which is 0, minus 1, everything squared. So that would be 1 times 1, and f dash would be 1. So then you can actually put the value in here as positive. Does it make sense? You do not need to actually show the value of f dash at the other points. You don't need to write 1 in here. You can if you want, but you don't need to. You can just write positive, right? And then the shape will go up, okay? And when you put the value 1 in here, we haven't calculated it, okay? We haven't calculated f dash of 1. But what you can show is that, I'm sure it's going to be positive because the question said, show that, not find the nature. Does it make sense? Sometimes you can cheat a bit if you know the answer, what the answer should be, right? It's supposed to be stationary point inflection. So if it's a plus before, it must be a plus after, and it has to go up after. You don't even need to calculate it. Or if you want, you can just write somewhere on the side, f dash of 1 equals to, and then you just quickly put that in here, so e to the power 2 minus 4 times by 2 minus 1, everything squared. Just write that more than 0. Good enough. Okay? Because when you do it, it will be more than 0. E to the power negative 2 is 1 over e squared, which is more than 0. Right? And then 2 minus 1 is 1, 1 squared is 1. So it's definitely more than 0. Okay? So then you can conclude, therefore, the only stationary point at x equals 1/2 is a stationary point of inflection. Okay. Does that make sense? Yeah? So that question is quite complicated using using different concepts in the second derivative chapter. All right. Okay. The next one I'll go through is question 4 here. There are quite a number of questions, so we'll see how many we can cover. There's like 33 questions. I only cover a few that I think is important. The other ones, you guys have to go back and practice by yourself, okay? It's going to be, the other ones are not too difficult. It's just the ones that I believe you guys might struggle a little bit with, because there are like 33 questions, and many of them are complex familiar. Did you guys bring your graphics calculator today?
Yep.
Yeah?
I didn't bring mine.
Didn't bring yours? Okay, I need to lend you mine. You got yours, right? Okay, good. We'll go through some calculator questions in the second half and see if you guys can use the calculator correctly. All right, now question 4. For fx equals to that, find the values of x for which the graph is concave up. What does it mean by concave up? What does it mean by concave up?
Second x values for the second derivative are less than 0.
No, the second derivative must be
Oh wait, more than 0.
more than 0, yes. Okay, so how do we find out when the second derivative would be more than 0? What do we do first?
To derive find the first derivative and then solve for x.
No. You find second derivative, right? You find second derivative, that's step 1. Step 2 is you set the second derivative to be equals to 0, and then you solve for x. Okay? Because remember, in order to find out where is more than 0, it's like when you have a graph of the second derivative, you need to find out when it is equal to 0, and then you find out whether it looks like this or it looks like this, for example. Right? If it's a linear equation and there's only one point, right, where the second derivative is equals to 0, then you got to find out whether it looks like that or whether it looks like that. Does it make sense? Well, so how?
Yeah.
You sure? Okay. So and then step 3 would be to find, substitute and substitute x values. Okay, x values to find when f double dash would be more than 0. Okay, so I will go through the steps here. So this question will be a little bit strange. The rest of it hopefully should be quite familiar. Okay, f dash would be 3x squared minus 6x. Okay, and then f double dash would be 6x minus 6. So then you set that equals to 0. Step 2, bring the 6 over, and so x would be equals to 1. So we know that when x equals to 1, the second derivative graph, right, the f double dash x, okay, second derivative would be equals to 0. But does it look like that or does it look like this? We don't know. Okay, we don't know that. Therefore, you need to test it with the value. So let's test with the value before 1, which is 0. Okay, then when you sub that into the second derivative, that would be 6 times 0 minus 6, which is negative 6. Which means that at x equals to 0, the second derivative is negative 6. So it must look something like this. Does it make sense? Why is it a straight line?
So when you when you double derive the cubic function, it becomes linear.
Correct, because this equation is a linear equation. Okay, so you need to start recognizing what type of equation each of these functions will be. Okay, does it make sense, Emily?
No.
No? Okay, thought so. So first, know that whenever you derive, so if the original is the cubic function, when you derive it, see how it drops the power by 1, becomes quadratic. And this is the first derivative, right? When you derive it again, the degree drops one more time to power 1, which is linear. And this is the second derivative. Okay, so you can think of it this way. If the, let's say if you have the original and then the first derivative and then the second derivative, if the original is, say, cubic, right? When you derive a cubic, you get a quadratic, right? And when you derive a quadratic, you get a linear. Okay, because the power drops by 1. Now, what happens when the original is, say, quadratic, or let's say quartic? So degree equals to 4. Then the next one degree will be equals to 3, which is a cubic function, and then the second derivative would be a quadratic. Does that make sense? So you just drop the power by 1 every time you derive it, if it's a polynomial. Okay, and that's why this one is a linear function. Linear just means the degree equals to 1. And the linear function, the shape is a straight line. Okay, so cubic function will normally have 2 turning points, and quadratic is the parabola, either go concave up or concave down, and then linear would be a straight line, either positive gradient or sometimes you get a negative gradient. That will be the straight line. Okay, and then looking at this way, because the second derivative at 0 is negative 6. All right, so if I were to draw that graph here at 0, this is the second derivative, it would be equals to negative 6. That means, what's the answer to this question? Therefore, concave up when what?
Is it when it's like more than minus 6 divided by
No,
like the x,
must be about x.
when x is more than 0?
Not more than 0.
Whatever.
More than 1, yes. When x is more than 1. Why? Remember, this graph is the second derivative. Okay? This graph is the second derivative. So when the second derivative is more than 0, what are we looking at? Sahar, what are we looking at?
If the thing's more than
Yeah. Which part are we looking at?
what do you mean which part?
When the second derivative
Yeah.
is more than 0, and this is the graph of the second derivative. Which part of that equation is more than 0? It is the part after 1. Does it make sense? It's more than 0, right? Yeah?
Yeah.
Yeah? So that's the answer. The part after 1.
Oh, are we looking at the y value, not the x?
Yes, because when you're talking about this is the y-axis more than 0, right? More than 0 is when? It's this region here for the y-axis more than 0. But when you read it, the answer is in x, right? So that part of the graph is more than 0, is positive, right? But what's the x value that you have to read? Well, the x is more than 1. Does that make sense? Because for the x more than 1, if I stop the graph, if I start drawing from 1 onwards, the graph will have to be positive, right? But if I draw from 1 backward, it will be negative, right? So that's why from 1 onward, the graph will be positive, and that's why the answer is when x is more than 1. This is very, very important. This kind of question will definitely come out regardless of whether you're in the tech-free or tech-active question, because this is the definition of the second derivative. You see how there's no concavity here? There's no concavity here because this is the graph of the second derivative. All right, so they will force you to link concavity to the second derivative because that's the big part of unit 4, all right, the second derivative. All right, so that's why I go through this question, is because this is a really, really important concept. You guys will have to go back and redo this question. See what kind of question this is? Simple, familiar. It's considered simple familiar because it's supposed to be simple and it's supposed to be familiar. It's nothing new. Okay, so if you find if there's anything that you are not sure of, better go back and redo this question. Okay, very important. Whatever question I'm going through today are the ones that I feel might be on the exam. Okay, so these are my guess on what kind of question that will be on the exam. So please go back and redo this one as a bare minimum. Okay, so I'll leave that be for now. Okay, the next one would be question. What time is it? Running a little bit low here. Okay, this one I will not go through the whole question. I'll just go through the idea for you guys. How do we locate stationary points and points of inflection?
Find the first derivative.
Okay.
And that equals 0 for the stationary points.
Yeah. So find first derivative, right? And then set that equals to 0, and then solve for x. What's next?
You go on second derivative.
Find second derivative. But wait, when you solve for x, you got what? The x value of the
stationary point.
Yep. And when you're talking about a point, you also need the
y value.
The y value, yes. So how do we find y value?
x0.
No.
Sub x into the original.
Sub x into original. Yes, sub the value into the original equation for y coordinate. Okay, I'm writing this in red is because sometimes you will see my answer later at some parts. You might see me doing this, and if you don't understand why I'm doing that, it will be very confusing. Or when do you sub into the original? When do you sub into first derivative and second derivative? So watch out for these. Okay, and then we do what Emily said, which is find the second derivative, and then what?
Solve x.
In order to solve it, you need to make an equation.
That equals 0.
Yep.
And solve x.
Yep. And then?
Then that'll give you the points of inflection, and then you sub the x values into the original to find the y.
Yep. And then you find the y coordinates. I will not repeat again. Okay. And then what?
Then you can find the x and y intercepts of the graph.
Yep. X and y intercepts if you can. Good. X intercepts and y intercept. Okay. And then we sketch the graph, but what are the steps to sketch it?
You put in all the points that we know.
That's right, put in all the points. And then? And then you sketch it, right? But you pay attention to what?
The shape.
Yes, the shape of it. Okay, so what do you mean by shape of it? Note that when you have like a turning point, right, it must approach horizontal gradient at the turning point. Okay, and if it's a point of inflection, the concavity changes. Does that make sense? So for example, like turning points or stationary points, make sure you note that in, and then concavity changes. Concavity changes. Okay, so pay attention to these ones when you do the sketching. Right, simple, familiar, not hard. Right, this is a very basic one. So what is the what type of equation is the second derivative, Emily? What type of equation will be the second derivative?
The cubic
Second derivative.
or quadratic.
Yes, it will be a quadratic equation. Okay, so when you sketch it, it will be a parabola if you need to sketch it. But no, the main equation is power 4, so it's a quartic function, so there will be 3 turning points. Could be up to 3 turning points. Okay, so that's all of the steps to do this one. Now, trigonometry, these ones are all the easier ones. Let's see. Okay, I'll just go through maybe one of these. Oh, actually, let's try this. Okay, all right. The 3 sides are these lengths. Find the cosine of the largest angle of this triangle. Which angle would be the largest one? So these are the 3 sides, right? Square root 2. Let's say square root 2 here. Okay, this is not to scale, okay? Square root 2, 2, and 1 plus square root 3. Is this in the correct order? Right? Is 2 larger than square root 2, and then is 1 plus square root 3 larger than 2? Because if I'm drawing it this way, I'm saying square root 2 is the shorter. Is that correct? How do you know? No, why? What is the estimated value of square root 2?
1 point something.
1 point something, yeah. So yes, it is less than 2. Now, is 2 less than 1 plus square root 3?
Yes.
Yes, why?
Because, square root 3 would have to be 1 point something. 1 plus 1 point something is more than 2.
That's right. So this is the correct graph. Does it make sense? Yeah? So you need to be able to estimate square root values. The easiest way is to remember the whole the perfect square. So square root 1 equals 1, and then square root 4 equals 2. So if it's anything in between, like square root 2 or square root 3, so this one must be 1 point something something something. Does it make sense? Yeah? Sometimes you might need to estimate a larger value. Let's say if you have square root 9 equals 3, they might have like square root 7. So you need to know this is about 2 point something something something. Okay, so that's how you estimate it, by relying on perfect squares. Alright, square root of perfect squares. Does it make sense? Yeah, Emily? Suleiman? Okay. Next, which angle is the largest one? Let's say A, B, and C. Which angle is the largest? A, B, or C? So this is angle A, this is angle B, this is angle C. Which one is the largest angle?
It'll be A.
Well, A, why?
Because those have the 2 shorter sides connecting to it.
Yes and no. So yes, it is A, but the reason is because the angle A is facing the longest side. Does that make sense? Yeah. Because remember, when you draw the angle, think of it as like like an eye, right? Where is it looking at? Because there's no this notation to draw the eye, like in physics. Have you seen that? Yeah? No? Yeah? Well, if you look at that, that's like your eye, right? You're looking in this direction here. Now you don't draw that eye because that's like looking straight into the outside of the screen. But if you draw it this way, then this eye is looking in this direction. Okay? So imagine the angle. When you draw the angle, imagine it's like an eye. What is it looking at? It's looking directly at that side there. Can you see it? Yeah? Yeah? So that's why this angle looks at the longest side, so the angle is also the biggest angle. Okay, this is year 9 geometry. But yeah, so that's why angle A is the largest angle, and we want cosine of the largest angle. Remember, this is tech-free. Tech-free means that you won't be able to get the actual answer for the angle, but That's why they ask you for the cosine of the largest angle. So we use the cosine rule. Then you would actually need to use, let's say, if you remember the rules and you have to adjust it, let's say you start with a squared, right? So this is the side that's facing angle A is the side A, this is the side C, this is the side B. So if we were to start with a squared, what would the cosine rule look like?
B squared plus C squared minus A squared. No. It's minus
Plus 2bc cos A.
Is minus 2 BC cos A, yes. Okay, and if they ask you to find cosine of the largest angle, they're asking you to just make cos A the subject. All right, and then we can actually put the values in. So we'll rearrange it first. So cos A would be, I might do step by step. So I take that whole term and move it to the left hand side. So that'll be 2bc cos A. Right, cos A is equals to b squared plus c squared minus a squared, and then I divide both sides by 2bc. So that will be b squared plus c squared minus a squared over 2bc. Any question? No? All good? Now we substitute the values in. B is 2 squared, c squared is just 2, and then minus a squared. Aha, now you got 1 plus square root 3 everything squared over 2bc. So that's 2 times 2 times root 2. That will be 4 square root of 2. Make sense? Yeah? So this one you actually will need to simplify it. So 2 squared is 4 plus 2 is 6. Now how do we expand this one? What's the expansion of that? 1 plus square root 3 everything squared.
1 plus 2 root 3 plus 3.
1 plus 2 root 3 plus 3. Yes, very good. Do you guys know how Suleiman got that straight away? How?
It's A squared minus 2ab, no, plus 2ab minus b squared.
No. You got the idea right, but it's the wrong formula.
Is it a squared plus b squared minus 2ab?
No. So a plus b everything squared equals to
A squared plus 2ab plus b squared.
yes, a squared plus 2ab plus b squared. Okay, remember if it's if it's a minus b everything squared is equals to
A squared minus 2ab plus b squared.
yes.
So the plus b squared doesn't change.
It doesn't change. The only thing that changed is the sign of 2ab. Okay, if it's a minus here, it will be minus 2ab. If it's a plus here, it will be plus 2ab. Okay, but a squared and b squared will always be positive. Okay, so that's how you can get this expansion quickly. Otherwise, it will take you a lot of time to get to this one. So over 4 square root 2, expand the brackets. 1 plus 3 is 4. So note that when you expand it, it will be minus 4 minus 2 square root 3 over 4 square root 2. And then that would be 2 minus 2 square root 3 over 4 square root 2. Divide 2 top and bottom. That will be 1 minus square root 3 over 2 square root 2. Any questions so far? Rationalize the denominator times the top and bottom, both of these, by square root of 2. Okay, so then the bottom would just be over 4. Any question for the bottom? No, then the top would be square root 2 minus square root 6 over 4. So this is going to be the final answer. Okay, so this is cosine of the largest angle, which is A. Okay, right? These little, in the tech-free paper, they would ask you a lot of like manipulations, algebra manipulations like that, possibly. Right, so that's for tech-free. So I'm just showing you guys this question as an example of working with certain stuff, which is grade 10 stuff, but could come out. All right, so that's the only trigonometry that I want to go through. The other ones, okay, actually I'll go through one more. Again, this is the algebra that I want to focus on here. Okay? Assuming you guys know your sine rules and cosine rule, then it's just the algebra. So ABC, AB is 6, AC is 4, and the angle BAC is 120. If you look at the angle here, which letter is the most important in this angle? A, the letter in the middle. Okay, the letter in the middle tells you what point the angle is at. Right, BAC means the point is A. So we were to draw that out. A, B, and C. AB is 6, AC is 4, BAC is this angle here, 120. So this is actually not correct, right? 120 is an obtuse angle. So you can choose to redraw it. Now I'll just redraw that again here. So this is an obtuse angle at 120 degrees. This is 6. Draw this one a little bit shorter. This is 4, and then this is AB, and this is AC. Okay? Alright? Now, how do we find BC? Using what rule?
Using the cosine rule.
Cosine rule, yes, good. And what is cos of 120 degrees? How is this related to cos of 60 degrees?
It's double.
It's 3.
Not double. Sorry? Not double. Anyone else?
Is it half?
Not half. Any other guesses? It's not double, it's not half. Is equals to negative of cos 60. Why?
Oh, because 120 is in the negative region.
That's right. Remember symmetry angles?
Yeah.
Yeah? Cos 120 is the same as cos 180 minus 60, right? And 180 minus 60 is your pi minus alpha. Is this one here. This is pi minus alpha. Second quadrant, remember, if it's symmetry angles, the numbers are always the same as the base angle. In this case, 60. Right? The sign is different, but the numbers are always the same. You have to be able to recognize this in the exam. Okay, symmetry angles. For example, if it's 60 degrees, then the symmetry angles are 120, 240, and 300. You see that? Can you understand that? Yeah. If it's 30 degrees, then the symmetry angles will be 150, 210, and 330. Does it make sense? Yeah? And if it's 45 degrees, then the symmetry angles are, what's the first one?
90? No.
No. If this is 45 degrees, what's the angle here?
Oh, 135.
135. And what's the angle here?
230, no, 225.
225. And the last one?
315.
Sorry?
315.
315. That's right. Does it make sense? Yeah, you got to be able to recognize these symmetry angles, because when you see a number like cos 135 in the textbook, you're like, what? How do we do cos 135? Symmetry angles. Okay, so you have to relate that to the back to the base angle. All right, I'll leave this here. So relate that back to the base angle, which is 60 in this case. So, and we know what is cos of 60?
Pi on 3. Or negative pi on 3.
Not quite. Wait, negative pi on 3? That's the angle, but the cos value is different. 60 degree as an angle is the same as pi on 3 in radians. All right, so yes, cos of 60 is the same as cos pi on 3, but what is the cos value?
Oh, the cos value.
Yep.
Is it 102?
1/2, correct.
Negative 102.
Yes, so yes, this will be negative 1/2. Why?
Using the triangle.
Using the triangle, yes. 1, 1, 2, square root 3. This is 60 degrees. So katoa, cos is adjacent over hypotenuse, 1/2. Does it make sense? Does it make sense? Yeah, you have to be able to make these very quick judgments. See, can't get stopped at cos 120 here. It requires a lot of concept from unit 2 and even unit 3 as well, but you guys have to be able to make that connection straight away. Go back practice, right? That's why I picked this question. This is one of the trickier ones, because they don't give you a straightforward angle. They give you a symmetry angle to work with. All right, but otherwise, it's just use the triangles for any exact value angles. Same with area. So you got to go sine 120. Is it going to be positive or negative? The answer for sine 120.
Positive.
Positive, yes. Why?
Sine is positive in the second quadrant.
Sine is positive in the second quadrant. Okay? Why? Because the sine axis is here. Right? This is the positive region of the sine axis. Right? So any angle in this region will have a positive sine value. Does that make sense? as opposed to cos would be in a negative region because you're talking about the horizontal axis. Okay, so again, I'm gonna go back and do more of these questions. Moving on. These ones. I'll use the very first one. Simple, familiar, but not so simple. All right. How do we find the first one? PR x more than 3 given x more than 1.
It's conditional probabilities.
It's conditional probabilities. Good. What's the formula?
It's PR of A.
A and B
Yeah, A.
Yep.
over P of B.
Yep. Okay, so apply the formula into this case. What would that be?
Probability of x greater than 3 and x greater than 1
Yep. Okay.
over probability of x greater than
Yep. Okay. So what does the top resolve to?
P of x greater than 3.
Why?
Because it's the only place that
they overlap.
overlap.
Yep. Emily, any question? Do you see it? Do you see that the top is just PR of x more than 3?
Yeah.
Yeah. Okay. Over PR of x more than 1. All right. So let's quickly give an explanation here. 1, 3, more than 1 is this. More than 3 is this. The overlapping part is only more than 3. Okay. All right. Now, what's probability of x more than 3?
0.1.
For 1. Correct. Any question? Emily? More than 3 means x must be equal to 4 because 4 is the only answer that's more than 3. So the probability is 0.1. Yeah? Okay, what's PR of x more than 1? 0.5. Any question? No? All good? Yeah, so that would just be 1 over 5. Okay? Same thing with this one here. It's just a conditional probability again. Work through that. How do we calculate the mean? Mean is E of x. How do we calculate the mean?
Don't you add all the values of
You do add all the values of
x and then is it divided by all the values of the probability values? Or
Okay, I'll give you a hint. Remember the formula. If you have a PDF fx, what's the formula for E of x?
A times x
into the equation.
That's right. Right? X times into fx, which means when you're given the table, instead of a function,
X times all the probabilities.
that's right, sum of x times its probability. Okay, so this one would be 0 times 0.3 and then sum to 1 times 0.2, sum to 2 times 0.1 and then plus 3 times 0.3 plus 4 times 0.1. Does that make sense? Okay, work through that, you get your answer. How do we find variance?
So you do the mean plus, or is it minus?
The mean, so EX
EX.
is wrong.
is ex squared, so you take the whole thing and square it.
No,
square
it's
X.
E of x squared.
Square the probabilities.
And then
Minus the mean squared.
minus the mean squared. Yes. Okay, I'll write it this way. Because the other way to write it is E of x squared minus E of x and then everything squared. Okay, so it looks complicated, so I don't like to write it in this version. Just remember, it's the expected value of, and then the x squared is inside it. What's the difference? How do we calculate this thing?
Just square the probabilities.
Not quite. How do we calculate E of x squared?
Like it's the same as the EX line, but you're squaring the decimal values. So
No.
or is it the
You
whole?
square each not term but each Actually,
What do we square?
So for example, like 0 times 0.3, square that, and then
No.
each one.
Oh, you square the x values.
Yes, you square only the x value. 0 squared, 1 squared, 2 squared, 3 squared, and 4 squared. Why? Guys, remember when you're calculating e of x squared using a PDF, right? This one would be antiderive of x squared, and then you times into fx dx. Fx is like kind of like a probability, right? And you square the x, not the probability. Remember that? And then you antiderive from the left to the right. So this is a separate formula. We'll see that a little bit later. But does it make sense? So if you remember how to calculate variance in the PDF version, right, you can use that to help you calculate variance and stuff in the table version. Okay, and the table version is one you have to do in the non-tech environment, because you can do 2 squared, you can do 3 squared, right? And then you also can work through these ones. Now 0 times that is 0, 1 times 0.2 is 0.2, 4 times 0.1 is 0.4. You should be able to do these questions, right? So yeah, should be easy. And then 9 times 0.3 is
0.27.
wrong.
2.7.
Yes, it's 2.7. It's 1 decimal place only. Okay. 4 squared times 0.1 is
1.6.
1.6. Yes, and then you got to be able to add decimal numbers and stuff like that. Yada yada. Keep going. Okay. So that's ex squared, and you know keep going in order to get that value, and then you subtract means the square of mean, and once again it's decimal number. That's how in one question they test not only unit 4 but all the way up to like grade 6, 7, grade 8 decimal operation stuff in the tech-free paper. Okay, so sometimes these questions do come up, so make sure you practice. All right, okay, let's go through 15 and 16. I don't know how much you guys remember of these ones, so I'll spend a bit more time on these topics here. All right. A bias coin is tossed 3 times. What is a bias coin?
It's like the probability of getting, let's say, heads is more than the probability of getting tails.
Well, almost correct. It's different from the probability of getting tails. You don't know whether it's more or less. Right? Normally it's 50-50. It could be 40-60. It could be 70-30. We don't know. Okay, so the idea is that the bias coin, the probability of getting a head is not the same. That's why they say it's just P. Question A, find in terms of P the probability that all 3 tosses show tails. How do we do this? How do we write this question?
Use the binomial equation.
That's right, it is a binomial equation, but how do we write it?
PR of x is equal to, big X is equal to small x.
Not just small x. That's a general formula, right? But
more than or equal to.
All 3 tosses show tails. What does that mean?
It's not equals to x.
No. I'll give you a hint. So the probability of getting a number of successes, right? And how many successes? Equals 0, yes. Does it make sense? Because all 3 shows tail, right? Which means that it's tail, tail, tail. So it's fail, fail, fail. So probability success equals 0. All right? And how do we write this in terms of P?
3, 0.
P times. Oh, no,
Not quite. P times? Not quite.
It's 3 and then 0.
Not quite. I know where you're coming from. That could work. Okay, maybe I'll show that one first. So 3, 0, and then?
Times by p to the power of the number of successes. So it's 1/2 times...
Not 1/2. Remember, we don't know. It's P.
Is it 0?
Yes, power 0, because 0 successes. And then?
Times
p.
1 minus p to the power of 3.
Yep. But you see, what is 3, 0? How many ways to choose 0 out of 3?
1.
1, that's right. And P0 is also 1. So the answer is just 1 minus P to the power 3. So what I was waiting for was for this answer here. Why do I want you guys to get to this answer straight away? Well, remember, in case of all successes or all failures, there's only one way, right? To get all successes or all failures. Okay, just remember, the probability of all fails, right? All failures or all fails would be 1 minus p to the power n, right? N is number of trials, right? Because fail all the trials. Similarly, probability of all successes, right? All successes is simply p to the power n. It's just the probability of success raised to the power of how many trials there are. Okay, so these two formulas must be you must be comfortable with these two. These are the special ones in the binomial case. Does that make sense? Right? Make sense? Emily? Okay. Now question B. If the probability of 3 tails is equals to 8 times the probability of 3 heads, find the value of p. How do we do this question?
We say PR of x is equal to 3 is equal to PR of x is equal to 3 times 8.
Like that? Wrong. Change it up. Got the right idea, but wrong equation. Try again. 3 tails. What does that mean?
What is this?
Oh wait,
Equals 0.
Yep. And then equals to that times 8 is the better answer. Does it make sense? Yeah? Or 8 times the probability of 3 heads, which is 3 successes. Yeah? Yeah? That make sense? So your mistake was saying that the first one is equals to 3. No, equals to 0. 3 tails means no successes. Okay? So we've got this one, 1 minus p everything power 3 equals to 8 times what?
p to the power of n.
P to the power of?
Oh, 3.
Of 3, yes. How do we solve this?
Make p the subject.
Good idea, not for this question. It's something else.
Can you expand the left side?
Good idea as well, but not for this question again. Something else.
Make it equal 0.
No, that's definitely wrong. Hint, index law. Index law. No? No idea? No? Emily?
Do you change, what's it called? Make all the powers the same, so change the 8 to power 3.
Yep.
And then you can cancel the powers, so 1 minus p equals 2p.
Yes, that's right. Why? Because first technically you need another line. You need to write this thing, right, is equals to, you have to combine these two, so it will be 2p everything to the power 3. And yes, now then you can say something cubed equals something cubed, therefore whatever is in the brackets must be the same, right? And then you bring p over to the other side, equals to 3p, and then 1 over 3 equals to p. That's it. It's a biased coin. So the chance of getting ahead is only 1/3. If you throw it 3 times or 30 times, you get 10 heads and 20 tails, right? Instead of 15-15. Okay, so that's what a biased coin means. Make sense? Yeah. Simple, familiar, but not very simple. Make sure you go back and redo these ones. Okay. These ones are hard. Okay, I'll skip a few of them. Okay, this one, question 17. A fair die is rolled 3 times. What is the probability that a 6 is obtained on all 3 rolls? How do we find this?
use the same formula.
Mm-hmm. How do I start writing this one?
P of x is equal to 3.
Yeah? Okay.
It equals is it 3 choose 3?
Yes, but remember,
Oh, that's just one.
if it's 3 times and all of them, you get a success. What's the formula?
It's p to the power of n.
It's p to the power of n, right? What's the chance of success?
1 over 6.
What's n?
1 over 27.
No.
Wait, no. 6.
1 over 216.
That's right, 1 over 216. Good. Right, it's just 6 times 6 times 6 3 times, right? Work it out, it's 216. Okay, all right. Question B. What is the probability that a 6 is obtained on at least 2 of the 3 rows? How do we write this?
Is it P of x more than equal to 2?
Yep. Okay, how do we solve this?
1 minus the...
You could, that could work, but for this question, if you go 1 minus PR of x less than 2, right? Remember, less than 2 means 0, 1, and 2. So it's actually longer because more than equals 2 means just 2 and 3, right? Because there's only three times. So in this case, you don't actually use the 1 minus version because it is longer. Right, so good idea though. Keep in mind the 1 minus version sometimes is really handy. Okay, sometimes doing that will make your whole question a lot shorter, but not in this case. So in this case, we use the normal version. What would that be? How would I write it next?
Do you have to do the same step you did for the first one twice? So for both for 2 and 3?
Yes, that's right. So the writing actually looks like this. PR x equals 2 and then plus PR x equals 3. Does it make sense? Because in all situation, it's 2 or more, right? At least 2, so 2 or more. So it's 2 or 3, which means you actually get the probability of each and you plus them together. You guys remember this? Yeah? Okay, tell me if your brain is slowly overloading. Okay? I can see that some people there are like, some of you guys sometimes check out in the middle of the question a little bit. Okay, so what's PR x equals to 2? This one we know is 1 over 216. What's this one?
It'll be 3 choose 2 times 1 over 6 squared times 1 minus 1 over 6, which is 5 over 6 to the power 1.
Yep.
So it's 5 over 6.
Yep, that's right. Plus that. Okay. What's 3 choose 2?
4.
How did you get 4?
The triangle, I forgot what it's called.
Let's see. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1.
Is it 4? No.
If it's out of 3, you're looking at the line that starts with 3 here. Alright? Because then this is 3 choose how many? 0. And the last one is 3 choose?
3.
Yep.
There's 3.
It's 3. So that would be 3 times, right? You just gotta times the top together, 5 on 216. Alright, because we did 6 squared times 6 already. Right, and then plus 1 over 216. So that'll be 15 plus 1 is 16 over 216. Non-type. Make sense? Okay?
Isn't it 18?
3 times 5 is 15 and you plus 1.
Oh wait, yeah, okay.
Yeah, over 216. All right. So yeah, so these are the kinds of questions that you could see in the tech-free one. That's a little bit harder, which is you have to use the Pascal's triangle and stuff like that. All right, let me see. We have a bunch more. All right. So we go I'll go through a few more of these ones. Actually, let's see. Okay, next one is 21. Covering a lot of content today. Okay, so tech free first, and then we'll have to go through some tech active questions later. See if you guys can survive the tech active stuff though. All right, how do we find K?
Would you anti-derive with bounds of 0 to 6?
And
Then make it equal
1 equal 1.
equals 1. Yes. Okay, so the idea behind question A is total area equals 1, right? It's a PDF. So yes, that is correct, and then you solve for K. So I'll quickly work through that. Anti-derive from 0 to 6, kx 6 minus x, the answer must be dx. The answer must be equals to 1. And then to work it out, you can take out k as a common factor first, right? And then you can expand, so that will be 6x minus x squared dx equals to 1. Okay, so then we anti-derive this one, that would be 3x squared minus x cubed over 3 from 0 to 6 equals 1. So k times, that would be 0, 0, so that will be 3 times 36. Okay. These questions, when you're working through something like this, what do we do? In a non-tech environment, no calculator, what do we do to make your calculation easier?
Take out common factor.
Take out common factor. 6 squared. What's left behind?
3 minus 6, 3.
Yep, which is 2, which is?
1.
Yep, so the answer is just 36. Okay, right? So yeah, k times 36 equals to 1. So k would be 1 over 36. See, take out common factor, tech-free technique, right? Much easier than doing 3 times by 36, which is like 108. And then you gotta do the subtraction later. Okay, so take out common factor, because most of the time it is a subtraction. Because remember, antiderivative is always the first one minus the second one. And normally it's a subtraction, that's why. Okay, how do we find question B?
Antiderive from 4 to 6.
Antiderive.
Is it less than? Oh, it's less than 4. So antiderive from 0 to 4.
Yep. Of, now you can take it out over here, 1 over 36, and then x times 6 minus x dx. Make sense? How do we do C?
Antiderive from 0 to x into the function.
Would you anti-derive from 0 to n?
0 to n.
0 to 0.5.
No. It's from 0 to m, and then the answer is 0.5. Alright, the area is 0.5 when you antiderive from the left to the median. Okay, how about mean?
Times in x to the function.
Times in x to the function. So for question D, the mean, as you went through this earlier, is antiderive from start to end of x times by fx. Right, dx. Work that through, you get the answer. Then these ones,
Antiderive from 0 to 2 and then use that for probability. No,
why from 0 to 2?
because it's x less than 2.
Yeah, but this is a conditional probability. What's the resolve condition? Can you see it?
X is less than 2.
Yes, correct. So yes, your answer was correct. So that was a lucky answer. You should have considered the conditional probability first, right? And then the resolve part is actually still less than 2 because it's saying less than 2 and less than 3. So it must be less than 2. So the same as your answer, right? But
how would that look if you're if you're going to like the big F notation? Can you do it that way?
Yes, you can. So actually, that's a very good point. How do we find use the CDF? How do we find the CDF? Big F of x equals to What's the formula? Remember, big F of x gives you the area to the left, right? To the left of a point x. So it looks something like this. Big F of x, let's say this is the function. Let's say this is the this is a PDF, right? Big F of x gives you the area to the left of a value x. Okay? Based on the original PDF. So how do we find big F of x? The CDF. You antiderive. Yep, from the left to
x.
To x, yes. From the left to x of f t dt. Remember, we're just changing x into t in order to have a, so that when you sub x and you don't get confused later. Okay, so I'll try it for this one. So this one you would antiderive from 0 to x of x times, I think 6 minus x. Yeah, x times 6, well, it's 1 over 36 of that. And then dx. Well, it should be t dt. So like so. Okay, that makes sense? Now, and this always gives you the area to the left of any x value that you get. Which means, if you are trying to find, let's say, probability x less than 2, and this would be the same as big F of 2. Any question? No? Emily? BF notation is a little bit tricky. So BF notation gives you area to the left of a function. So if I were to work this one out, it will get you something like this. So 60, so that would be times by 3t squared minus t cubed on 3. Doesn't it look familiar? It's like similar to what we did up here, right? It's this one here.
Oh.
Okay, but we wrote it in this form so that so it will be from 0 to x, right? And then when you sub it in, then we know the area to the left of a value is always 1 over 36 times by 3x squared minus x cubed over 3, right? And this is the area to the left of any value x. Okay, so this is the CDF. And remember, when you write the CDF, you need to write it in as a piecewise function as well. Okay, so it will be this value, 3x squared minus x cubed over 3, for what values of x? Alright, so we calculated the big F of the big F notation, and it will be this answer when x is between the range that it was specified in the question here, from 0 to 6. Right? So from 0 to 6, the area to the left will be specified by that equation there. Alright? But how about when it's less than 0 and when it's more than 6? Less than or equals to 0 and more than or equals to 6. What would be the big F notation? What would be the area to the left? Let's say this one. What's the area to the left?
It's just 0.
It's 0. Good. How about this one?
1.
It's 1. Yes. Any question? No? Emily? The reason for that is because big F notation, right? It will, let's say from 0 to 6, right? So the area from here, it will reach 1. Right? The big F of x formula will always reach 1 because the total area is 1, right? But then after that would just be constantly 1. Right? Because in the main function here, from 0 to 6, any point after 6, like at 7, the area will always include everything from 0 to 6, which is 1, from 6 onwards. Right? Because area to the left. Yeah, so it will be 0 here and then every single area in this section here.
Yep.
Yeah, that is why. Okay, so running it this way. So let's just say we're trying to calculate question E, right? Yeah, question E. So question E. PR of x less than 2, given that x is less than 3. So if you use a conditional probability, resolve that, it would be x less than 2 over PR of x less than 3. Alright? Which means, using the big F notation, it's just big F of 2 over big F of 3. Because less than. Alright? It's just error to the left. Okay? Big F of 2 is just basically punch 2 into this one here. Alright? So that would be 1 over, alright, 1 over 36 times by 3. 3 times 2 squared is 4, and then minus 8 on 3, and then everything over 1 over 36. You see, if we leave the constant out, you can just cancel the constant straight away. Okay? Then the bottom would be 3 times 9 minus 27 over 3. Okay? Does it make sense? So using the big F notation, if you can find the CDF first, and Emily, you should go back and practice finding the CDF. If you have any question, go back to the CDF chapter, which is, I think, 16E or something. Okay? Practice the CDF, look at some examples, it will make a bit more sense. Because if you have to do like a bunch of calculations like this, like a bunch of probabilities, using the CDF is a lot shorter. Okay? It's a lot shorter using that. So yeah, so for example, in this case, the two things here will cancel out. I'll change the color. Those two will cancel out, right? And then the top is, you can resolve the top easily, is 12 and then minus 8 over 3. I want to write it as a separate part here, and then I write divide by, the bottom is 27 minus 27 over 3. Okay, so work that out. 3 times 12 is 36 minus 8. I didn't take out common factor. You can if you want to, but in this case, I will just try not taking out common factor. So 36 minus 8 is 28 over 3. And then divided by, so that would be 3 times 27. Now this one, I will take out 27. So you would think it as, take out 27, it will be 1 minus 1 over 3. Right? Which is 2 over 3 times by 27. So that's 54 over 3. So that's divided by 54 over 3. Dividing a fraction is times by the reciprocal. Okay? And then once again, 3 cancels out. So that's 28 over 54. Divide both by 2, 14 over 27. Okay? Go back, try these ones. Alright, exams are coming. You've gotta work on these harder questions this week. This is the only week. Alright, next week, after I see you guys for next week, I'll go through all the main concepts once again. I will only go through the basic concepts, okay, and some of the more advanced techniques here and there if I do remember. But next week is to cover every single basic concept, and then you guys just do focus on the simple familiar questions, okay, to reinforce them. And if you can, try some complex familiar, complex unfamiliar. But this week is the only time that you can try to relearn some of these concepts here and try to do some of the harder questions. All right, next week you got to build up the speed for exam. All right. Okay. Question F. How would I write question F using the big F notation? Okay. So first, what's the resolve condition here? More than 2 and less than 4. If you add them together, it will be?
2.
Sorry?
PR of 2 less than equals to x less than equals to 4.
Less than only. But yes, 2 less than x less than 4. Okay? So this one, more than 2 means here, right? And then less than 4 means the opposite direction. So the parts that overlap is between 2 and 4. Okay? Over PR of x less than 4. Okay, so we know the bottom less than 4 means big F of 4. Alright, so this one would be, the bottom is just big F of 4. How about the top?
Anti-gravity powers would be 4.
Yes, but using the big F notation.
F of 4 minus 1 minus F of 2.
No, it's just F of 4 minus F of 2, that's it. Big F4 minus big F2.
Oh, yeah, okay.
Does it make sense?
Yeah.
Emily? Maybe? Yeah? It's the area to the left of 4. Let's say this is a graph, right? Area to the left of 4 is this whole thing. And then area to the left of 2 is this thing. So when you subtract that, you get the area in between. Does that make sense? Yeah? So area to the left of 4 minus area to the left of 2 is between 2 and 4.
Would it be easier to do the antiderivative between bounds though for the top?
For the top from 2 to 4, well, yes and no. If you do that, you actually will have to do the exact same thing, but you have to antiderive twice. Because when you sub it in, right, the idea is that if you use the second derivative, you sub it in first, get the answer, and then you subtract them separately. As opposed to, I guess in this question, you may argue that the top one might be a bit easier, potentially, because you can take out the common factor. So for example, say this one, right? This is big F of x, right? So I remember this. So if I were to calculate, let's say big F of 4 minus big F of 2, the first one, they both have 1 over 36 as a common factor, right? So that'll be 1 over 36. And then this one would be, what was it? 3 times 4 squared. So 3 times 4 squared minus 4 cubed over 3. Okay, and then minus 1 over 36 of 3 times 2 squared minus 2 cubed over 3. So you see, even if you work out big F4 minus big F2, it will still be shorter. There's no antiderivative. You don't need to antiderive anything anymore. Alright, so I really encourage you guys, if you want to go for speed in the exam and score well, you have to practice this the CDF, okay, or the big F of x notation. Remember in Unit 3, we learned big F of x, but not in the probability context, and it's so handy, right? To calculate area, it's just big F something minus big F something. It's so easy. In the probability realm, it's the same idea. If you calculate the CDF, if you give them PDF, you calculate CDF, it makes many of the calculation a lot easier because you can do them separately and then just subtract them at the end. But say for this one here, right? You can take out a common factor 1 over 36, okay? And then inside here, you can just work each of them out. So for example, this one, I take out 4 squared, then I would get 3 minus 4 over 3. Okay? Alright? And then after that, minus, I take out 2 squared, then in the brackets would be 3 minus 2 over 3. So same thing. You can still take out common factors before you actually work to the numbers. Okay? To make things a little bit easier. So yeah, so that's all for the CDF. I think the rest of the questions could be a little bit tricky to go through. Now I'll go through, let's see. Okay, I'll go through some of these questions for sampling and estimation here. Some of them are quite tricky. All right, see if you guys can follow. And then in the second half, we'll go to the calculator questions instead. I might, yeah, I'll see how you guys go. I might scale back to do this, something that's a little bit easier. Okay, this one. Suppose that an approximate 95% confidence interval is given by these two values. Write down the expression for the sample proportion in terms of A and B. You guys remember the formula for confidence interval?
The Z one.
Yeah, the one that has Z in it, yes?
Z is equal to the square root of P times 1 minus P over N.
Yep. So Z, it's times by square root of P hat times 1 minus P hat, or population proportion. So yeah, so P 1 minus P over N, yes. Okay, and what is this formula equal to?
The margin of error.
Yes, it's the margin of error. ME, or just E for margin of error. Okay, alright, so what's the confidence interval? What's the formula for a confidence interval?
Also 1 plus what?
Not 1?
Oh wait, is it the margin of the Z formula?
Yep, so it's either plus or minus, but what plus and what minus?
Is it P?
P hat or the population proportion. Okay, so it's P hat plus the margin of error or P hat minus the margin of error. Technically you minus it first, right? Because you get the lower number, and then you plus it to get the higher number. Okay, so yeah, that's right. So it's just using that formula. So for 95% confidence what's the Z value?
1.96.
Yep, Z is 1.96. That's right. Okay, all right. Now, write down an expression for the sample proportion in terms of A and B. How do we do this? Sample proportion, again, it's P hat, all right? And remember, they're saying that the two intervals are A and B. So the left is A and the right is B, which means that you've got A equals to P hat minus the margin of error, and B equals to P hat plus the margin of error. How do we get P hat in terms of A and B? This is a simultaneous equation. So you add the two equations together. Why?
Cancel.
It will cancel out the margin of error. Yeah? So then you got A plus B equals to 2 P hat. So essentially the sample proportion is just A plus B divided by 2. And when you think about it, it makes sense. Because when you have a confidence interval, let's say from 2 to 4, right? How do we get the sample proportion? It's always in the middle of 2 and 4. So it just be the lowest number plus the highest number and divide by 2, which is 3. Right? So if that's for like the midpoint. This is the midpoint formula back in year 9 geometry. It's the midpoint formula. Now how about this one? Write down an expression for the margin of error in terms of A and B. So how do we write the margin of error in terms of A and B?
Would you sub in the A plus B over 2 into P hat?
Yes, you can. Yes, you can. So remember the okay. So A is equals to P hat minus the margin of error, right? And then what's the house set is to take this one, sub into P. Yes, you can actually do that. So if we were to work that one out, that will be A plus B over 2 minus the margin of error. Move the margin of error onto the left hand side, and then do one will be minus 2A over 2. Right? Yeah, because it will be minus A, right? And I change A into 2A over 2. So that would be A minus 2A is negative A. So the top is B minus A over 2. Yes, this is the margin of error. But when you really think about it, the margin of error, let's say this is the proportion 0.4 and this is 0.6. What's the margin of error? Well, you just take the bigger one, you minus the smaller one and have it. Right? Because the margin of error is just 0.2 here, from here, 0.1 from here, and then 0.1 from here, right? Equal on both sides. So you just take the total and you have it. But yes, you can also use algebra to work through this question as well. Okay, so in the exam, most likely you will start with using algebra, and then when you think about it, you're like, oh yeah, that makes sense because of whatever. Okay, so yes, when in doubt, rely on algebra first, because sometimes the intuition doesn't come that easily. Okay, all right, so that's confidence interval. Okay, you know what? I'll pause it here. I'll still need to do a few of these tech-free questions in the second half. Okay, but I'll pause it here for now. Okay, let's continue. The next question will be question 30. So these questions are mostly from chapter 18, the sampling one. Okay, which is the last chapter that you guys learned, and also arguably the trickiest chapter conceptually. I have a feeling that you guys will struggle a little bit with this last chapter here. Hi. You remember this idea of sampling and sampling from a large population versus a small population? Remember? Yeah? Vaguely?
Yeah.
A committee of 4 is going to be chosen from a group of 5 men and 4 women. Okay? So what's the total population here? 9. So very small, right? Only 9 items or 9 members of the population. And then P hat is a random variable for the proportion of males in the committee. These are the possible values of P hat, the proportion of males. How do we do that?
Use a table.
You don't need table for A.
Where's the point? Oh, for B you do.
Wait,
0 over 5, 1 over 5, 2 over 5.
Not quite.
Four. 4.
0 out of... Wait.
Not just 4. P hat is the proportion of males in the committee. So you take a small sample from this group of 9 people. The committee is that sample. So what's the possible proportion of males in that committee?
5 over 9?
No. When you get 4 people, right? Out of 9, right? You could either get 0 males out of the 4, or you could get 1 out of 4, or 2 out of 4, 3 out of 4, or 4 out of 4. Does it make sense? So like male, let's say, all right, male, and then female. If you take random 4 people, 1, 2, 3, 4, that means 2 males. The proportion is 2 out of 4. Alright? If you take 1, 2, 3, 4, then that's 1 out of 4. Right? Or if you randomly pick, you could get 1, 2, 3, 4. So that's 0 out of 4. Okay? So that's what the proportion, the sample proportion means, the p hat value. Okay? B1. How do we find PR of p hat is equals to 0?
Do the B5 give the 5 0 times by 4 and then over 9 4.
Yes, that is very good. Any question here?
How did you get that?
Lost that? Okay. Remember, this is small population, right? When you're sampling from small population, the probability that, let's say, the p hat is equals to, let's say 1 over 4, for example, right? Okay, would be, so 1 over 4 means 1 male chosen out of 5 males. So you need to find, okay, how many ways, so the brackets always will look like that, okay? And then what's in the brackets will be, well, there will always be 5 males, 4 female, and 9 in total. And in the committee, there's always going to be 4. So these numbers will never change, okay, for this scenario. Now, 1 male means out of 5, you choose 1. So in the committee, if 1 is male, then 3 must be female. Okay, and this would be the probability of p hat equals to 1 over 4. So do you remember this formula?
Yeah.
Yeah? If this is, let's say, 3 over 4, that means out of 5 males, you choose 3. And then out of 4 females, you only choose 1. And then the rest is the same. Okay? Yeah? This is for small population. Why? Because when you pick a male from the list, the probability of getting a male is reduced, right? Instead of 5 out of 9, it's now 4 out of 8. Okay? If you pick another male, then it reduces to 3 over 7. So because the population is so small, when you pick out one person from the population, the probability of getting the same category changes significantly. Okay? So that's why for small population, you would use this formula here. What formula do we use for a large population? You guys remember? If you're sampling from a large population, what do we use? Large population, which is, let's say, all students in Queensland, right? A couple 100,000. Okay? And we're trying to find out how many students uses social media. Remember this one? So if you pick someone and they use social media, what do you think is the chance of picking the next person who uses social media? Would it change much? No. Right?
Is it, did you choose the binomial?
Yes, large population you use binomial. Okay, is the binomial formula. Okay, but remember, to use the binomial formula, instead of doing p hat equals, let's say, 1 over 4, you need to convert that into PR of x equals to 1. So 1 success out of 4 trials. Yeah, does it make sense? So let's say in a committee of 4, let's say you pick like from the whole population, so the chance of male and female is the same, right? And if you pick a male, the chance of the next person being male is also about the same, right? It doesn't change. So if you pick 1 out of 4, okay, the chance of it to be 1 out of 4 means out of 4 people, 1 success case. Let's say you're trying to go for female, so 1 female and 3 males, right? So that's probability of success equals to 1 in a scenario where the number of trials is 4, and then the probability is whatever is the given probability, and then the success number is 1. Remember this one? This is a binomial distribution. Make sense how? On there. Okay, I might use an example. But back to this one here. So probability P hat equals to 0 is this formula here, and this is just Pascal's triangle. Okay? 9 choose 4, well, you gotta make the Pascal's triangle all the way up to 9. Okay? So 1, 1, 1, 1, 2, 1. So this is for number 2. 1, 3, 3, 1. This is for 3 choose whatever, and you need to keep going until you get 9. Okay? But the rest of it is pretty easy. Now the second one, this one would be equals to what? How do we find this one easily? Probability P hat more than 0. How do you find question B2 easily? Emily?
You use a 1 minus 1.
You use a 1 minus 1 here, right? More than 0 is 1 minus probability P hat equals to 0, which is the answer from B1. That make sense? Yeah? Because there are only 5 possible values, right? This is like the table that we did earlier. This is like that table there. But instead of them giving you guys the table, you have to calculate the table yourself. Okay, so that's the main idea behind this question here. Any question? No? Okay. And then P hat equals to 1. Yeah, it's just the same thing again. Okay, let's see. Let me try to find the okay, say this one, question 29. Then we might need to move on. All right, in a large population of marsupials, remember large population, right? When we're sampling from large population is a binomial distribution. So the proportion of animals with a particular disease is 25%. Okay, and P hat is the random variable represent the sample proportion of animals with the disease for samples of size n, so the size is n, and then find the smallest value of n such that the standard deviation is less than or equal to 1/50. Okay, in a large population, what's the formula for standard deviation? Okay, do you guys remember the formula for standard deviation in the binomial distribution? Right, on the side here, right? If it's a binomial distribution, what's the formula for mean and standard deviation? Remember, binomial distribution is always categorized by an n value, a probability, and depending on the question, the number of successes. So the two main parameters are actually n and p.
Is the mean just n times p?
Is n times p? Yes. What's the standard? What is the standard deviation?
Is it square root of p times so 1 minus p over p?
Okay, you're close. It's np 1 minus p. But remember, the binomial distribution is the one where it's like number of successes and failures. In this case, we're talking about the sample proportion. So the expected, now these are the main formulas here. The expected value of p hat. Okay, think about this for a second. In this large population of animals, right, marsupials. In this population of marsupials, like lots of marsupials, like let's say thousands. Okay, so it's large enough. If you take 100, right? If they say that the proportion of marsupials with the disease is 25%, if you take 100 marsupials, how many do you expect? What's the proportion of marsupials in the 100 do you expect to have the disease?
100 times 25%.
No, it's just 25%. Does it make sense? Okay, put it this way. Let's say the ratio of males and females here in Australia is 50-50. Right, let's say we know that. It's 50-50. Okay? If you pick 100 people, how many do you expect to be male? 50. Right? So the proportion is 50 over 100, which is 0.5. So the expected value of the sample proportion for a large population is exactly the same as the population proportion, P. Right? Because in the sample you expect to be the same as the main population. It will be different, and the distribution of that is the normal distribution of But putting that aside, the expected value you expect it to be the same. So then the variance, right? The variance of p hat. Now note that p hat is a little bit different from binomial. See, binomial is n times p, but this is just p only, and that's actually because it's np over n. Okay, because in a sample you have a sample size, so you need to account for the sample size. So the variance is actually p times 1 minus p over n, and the standard deviation is just square root of that. Okay, yeah, make sense? Maybe, hopefully. Okay, so that's the variance, which means that let's see. So P, so we know P is 0.25 or 1 over 4, right, based on the question. Okay, and then they ask what is the smallest samples of size n such that the standard deviation is less than or equals to 1 over 50. So they're saying the standard deviation is less than or equals to 1 over 50. And what's standard deviation? Well, this is just the square root of P1 minus P over n. Okay? All right? And what's P times 1 minus P? P is 1 over 4. 1 minus P is 3 over 4. Okay, so that's just 1 over 4 times by 3 over 4. So square root of that over n less than or equals to 1 over 50. If the square root of a number is less than or equals to 1 over 50, when you square it, when you square both sides, it must also be equal to less than or equal to the other one. So 2500 would be less than or equals to that thing. Okay? It's like the idea where if you have x, square root x is less than 3, then x also must be less than 9. Okay? Well, when you square both sides, just cancel out the square root. Alright, and then you do, you can actually just work this one through. So 1 over 4 times 3 over 4 is 3 over 16, and then divide by n is times by 1 over n. Alright, less than or equals to 1 over 2500. And work through this one. So this is inequalities, one of the harder types of equations. When you're working with inequalities, there's only one thing you need to pay attention to. Okay? Which is what? Does anyone remember?
Where the sign's facing.
Yes, correct. And what happens to the sign when you divide or times by a negative number? It flips it. Okay? So for example, if x is less than negative x is less than 3, then x is more than negative 3. Okay? So when you multiply or divide both sides by negative 1, the sign flips around. Just remember that for inequalities. Okay, and now you're gonna work this one out. So I times n on both sides and 2500 on both sides to move things around. So times n on both sides, the n will cancel on the left hand side. So it'll be 3 over 16 is less than or equals to n over 2500. And n is just a positive number, so nothing changes. Okay, and then I times 2500 both sides. So the left would be 3 times 2500 over 16, and then the right hand side would just be cancelled out. Okay? So n must be greater than or equals to, so let's rewrite it. Greater than because they ask for the smallest. Alright, so we find the smallest number that will satisfy this. Okay, how do we work this one out? The algebra is not easy, but you can work through it. So instead of dividing by 16 straight away, I'll divide top and bottom by 4. So note that 25 is the same as 25 times 100, right? And 16 is 4 times 4. So I'll take 100 divided by 4 first. So it'll be 3 times 25 times 25 over 4. Okay? In the textual environment, you just gotta work through it. Okay, it's really not much you can do. So 3 times 25 is 75 times by 25. Yes, do the multiplication. 2, 35, 37, and then that'll be 150, 1875, and then you gotta divide that by 4, 1875. Divided by 4 is 4, remainder 2, 27 would be 6, remainder 115 is going to be 3, remainder 3, and then 3 would just be 0.75. So 463.75, which means that, alright, so n must be equals to 464, for example. Okay? Let me check the answer to make sure my calculation is actually correct. Oh, the answer is 469. So that should be 468. Did I miss something? 25, 5. This is 2, 25, or 27. What did I write? 37. Yeah, that'll be 7.
Isn't it still, no, isn't it 1875? Is it 625 times 3?
Sorry, what was that?
Because if it's a 25 times 25 is 625. 625 times 3 is 1875.
Oh yeah, it's 1875, yeah. Yeah, it should be 1875, yeah.
Is something with division?
Oh yeah, this is, yeah, maybe it's something with the division. Let's see. Okay, I might do a long division this time just to be sure. So 416 subtract that 2, 27 is 6. Yep. 24, 3, 35, that's right, 468. And then there'll be 32, remainder 3. Yeah, so 0.75, 468.75, my bad. All right, and then 469. Okay, but anyway, the main idea here is that the expected value, so for a large population, for a large population, the expected value is just the population proportion. Okay, and then the variance is this formula here, p times 1 minus p over n. Okay, so that's the formula for the expected value and the variance of the sample proportion in a large population. Chapter 18 is not easy. Okay, I'll tell you guys that. Chapter 18 is not easy. If you guys find yourself struggling a little bit with it, you have to go back and try do more questions from chapter 18. Okay, you can go all the way to the chapter review in chapter 18. Alright, because that sheet there, the part for chapter 18 is a little bit difficult. Based on the question, it's mostly complex familiar, so a little bit difficult. So you should go back to chapter 18 and try out the chapter review questions, or even like just the questions in each of the chapter 18 A, B, C, D. Okay. Okay. All right. I don't think we have time for calculator questions. I have to rely on you guys doing a bit more of the homework. Okay. Now, in that sheet there are multiple choice questions. If you're really lazy, just try these ones. Okay, at least try these ones out if you're really lazy. Now, the reason why I want you guys to try out the multiple choice question is because these questions, the answer, for example, like if let's say B is the right answer, I'm not telling you guys what it is, but let's say B is the right answer. How they make A, C, D, and E is that they will intentionally make a mistake somewhere. So if you make the same mistakes, you will be like, oh, I got the answer, that's the right answer. Wrong. Okay, and then you can see, wait, hang on, what kind of mistake did I make? And then you can learn from your mistakes. Okay, so I will not go through these multiple choice questions. You got to do it first, and then if you get it wrong, check and try to find out why you got it wrong. Okay, if you don't understand, then send me the answer. Maybe, oh, hey, cool, I don't know why this one they get the answer B, and I'll explain. Okay, but you're gonna make a mistake first. All right, to see if to see if you made a mistake. If you don't, then that's good. And if you have no idea what to do for that question, then also ask me. All right, because sometimes, for these multiple choice, I don't want you guys to guess the answer. I want you guys to know exactly what the answer is. Right? If you don't know exactly what the answer is, then you gotta ask me and I'll give you an explanation, then it will make more sense. Okay, but I want you guys to think about this first, because sometimes these multiple choice, if you look at the answer here, you might be able to guess it, like, oh, it's concave down on the interval, and you see the answer is like some sort of interval, right? And some has negative infinity, some has positive infinity. So sometimes it might help you figure out, like, oh, what kind of question is this? What kind of answer are they looking for? Okay, and there are 43 multiple choice questions. Right? See if you can go through these questions. Some of them are actually quite interesting. Some of them are like the simple familiar in chapter 18. For example, the last question here. If the researcher decreases her sample size by a factor of 2, then the width of a 95% confidence interval would do what? Gotta work it out. Alright, gotta use the formula and work it out. So this is one of the slightly harder ones. Okay, and the trick is, I'll tell you a trick for this one, for example, is decrease the sample size by a factor of 2. Sorry. So instead of writing sample size, you write n over 2 in the formula. Instead of n, you change n to n over 2 and see what happens to the formula when you rearrange it. Okay, not easy, but try it out. And remember, if you can't figure out the answer, just ask me.
Would it be E?
Why?
Isn't it decreased by a factor?
No, you have to work it out. You're guessing. You have to work it out. You have to give me you have to give a really strong answer. Okay, so it's not about getting just the right answer, but you kind of be like, I'm sure this is the right answer. Okay, because there are 43 questions, I can't go through all of them. There's not enough time to go through all of them. So you guys have to go through it, and then the questions that you guys don't know or you guys not sure, even if you are not sure, just ask me. Yeah, hey Coy, why is, can you please explain 19B question, I don't know, like 35 or something. I have the same sheet as you guys. So make sure you ask, and then I will answer. All right. What I intended for you guys to go through with you guys is these ones here, extended response, but I don't think we'll have time to, so I'm going to bet on the fact that this exam hopefully is a bit easier, because these questions, some of them are on the same level as the external exam, which is really difficult.
Isn't there 10 multiple choice and external exam?
Yeah. But even these extended response questions here, they're all complex familiar. Alright, so if you have time, then try to practice some of these this week. Otherwise, just practice the question that I mentioned to you guys, the top part, practice by topic, and then get to this one here, 19D. Degree of difficulty classified questions. Because remember, the goal for the last week is just to go through the simple familiar stuff, and which actually include these kinds of simple familiar questions. Okay, so reinforce your knowledge. So that's what I will try to do next week before your exam. Okay, because your exam is in week 3. What day is it? Tuesday? Yeah, week 3 is Tuesday. Yeah. So next week is week 2, right? Next week is the last week. Okay, and after that you have to do your unit 4 exam, and we're not stopping because I will start you guys straight away on the external exam preparation. Okay, so you guys will be doing more and more math questions right after the exam, because I'll be honest, I don't think you guys are fully ready for the unit 4 exam. I'll be honest. Okay, given like say 2-3 more weeks, you guys might be a bit more ready, but I expect you guys to at least get 10 out of 15. Okay, 12 will be good. Anything above 12, I think, is a miracle. Okay, for unit 4. In saying that though, I've got a lot of students who did not do so well in unit 4. Did not do so well as in they got 11. Right? Like, I don't think any of my students got like anything below 9. 9 is like the lowest of the low out of 15. Okay, it's the lowest of the low. No one got below 9. Okay, so you please do not break that record. Okay, make sure you get at least 10. Right, 10 is still okay. 66% scales to 80 something, which is still okay. Alright, so 10 is still okay. Ideally, get 11 or 12. Anything above that is needs a bit of luck. Then you see this complex and familiar. I know exactly what to do, and then you get full marks for CF and CU. Then there's a chance you get like 13, 14 out of 15. Okay, but for this one, as I said, aim to get a solid 10, at least a solid 10 out of 15. Okay, 11 good. 12 also very, very good. But if anyone can get 12 out of 15, I'll be happy. Right? Because we are lacking just a little bit of preparation. I wanted this lesson to spend a bit more time on calculator questions, but we don't have time, so you guys have to go back home and try the. You can even do these questions, the one that were in that sheet before, but do that with calculator. Okay, sure, it could be simple, but it's practicing punching in calculator to remember where the functions are. And sometimes for the questions in kinematics, you can use a calculator to sketch the graph and try to find the answer without doing algebra. Okay, because in the calculator questions, it's basically the same idea, but the numbers with decimal. That's most of the time is that's what the calculator questions are like. Okay, and then they'll ask more. So if you can do the basic stuff easily, then in the calculator paper you can like see what else do they ask from these questions. So please go back, practice the one that I mentioned that I went through today, as well as some calculator questions. Okay, if you don't know whether it's calculator or not, just use the calculator for everything that you do. All right. So assume it's calculator because the algebra ones, just practice the one that I mentioned for the algebra is good enough. If it's tech-free in the chapter 19D, you know it's tech-free. But if you go back to the other chapters, let's say if you go to chapter 17 and you get the sheet for chapter 17, or you go to the textbook chapter 17, just do everything with the calculator. Okay? Because the last few weeks here before the exam, you have to get used to your calculator. Very important. The calculator exam is like half of your entire exam. Okay, and the questions in there requires you, like if you see it, you're like, oh, I need to find the maximum point. You know exactly how to get maximum point. Or if it's like an application question, you know exactly how to set the window to see the graph, and then you can find like the y value given the x value, or you calculate the x value given the y value and stuff like that. Okay, so so the strategy is, again, I'll mention that again. For non-calculator, go through the one that I mentioned today in the recording. Okay, I'll send you guys the notes as well, so go through those ones, and if you have time, go through other ones in chapter 19a. It's all tech-free in the revision, and then when you're ready, you can go through previous chapters, but use calculator for every single one of them to practice your calculator skills. Clear? Okay, last week for you guys to learn new things. Next week is all revision only, like pure easy revision, revision of the basic concepts. Okay, I'll try to get a list of all the concepts, and I'll go through a bunch of concepts with you guys to make sure you understand every single concept and revise every single one of them. Okay, and then that's it, exam. Okay, how ready do you guys feel? Suleiman, out of 10.
5.
5? Emily?
Around the same.
Around the same? Sarah?
Same.
Around the same? Yeah.